Alright, so this is the audio portion. Just going to start off with a demo, and the demo has this music that is just represented visually by a red ball in the center, and there's a listener in the scene that is attached to the camera, and there's not positional audio. I wasn't able to get that working, but I got the volume attenuation to work, and I was also able to get the reverb send to be separate from the dry signals, so when you go closer you hear more dry sound, but when you go back it sounds like you don't hear the direct sound as much and you hear the reverberance of the room, which is set to a plate here, and when I go behind the cottage in this scene you'll see that there's an occlusion effect, and that is brought on by this occlusion line collidable, which draws a line basically from the listener's position to the sound source's position, and if any game objects collide with that line, then an occlusion effect is applied. So this is the sound test. Yes, so that is sound. Part of this presentation is going to be kind of differentiating what parts were done in this class and what was done in the audio engine class, and a lot of the API work and actually usability parts, as well as bug fixes and making that 30K switch statement go away, were some big parts of this. There's no Alright, before this class I hadn't had the reverb or the filters or anything working, so with that in mind I'm going to show you a class diagram of the entire system, but a lot of this multi-threading was done last quarter. So you have your game thread here. It makes a sound call that you load in the load resources, or you load the audio files in the load resources, which goes over to the game thread, which tells the file thread to load it, which then tells the audio thread at one point that it's done loading. And then when you are using the game, you go into a sound call and you get one of these sound call IDs to get whatever sound or script you loaded. As I talked about a little bit in the documentation, you can actually load text files with different audio commands to go off sequentially and have multiple audio files play. But I probably broke that when I refactored the audio main loop today, which I think is worth it. As you saw, that was a really big switch statement, which is now down to just this little thing in the main loop, which turns out is a visitor pattern, essentially. It takes in the command type, which the type is not strictly a type. The type is an object that has a visit method. I can show you. So it returns an audio command, and then you set the context to the other metadata that you had inside of the command, and then you execute it. This went from a 30K switch statement to 120 separate files. It's been a long day. It was all today. I just decided to do it. And they all just kind of are very simple. They just have a set command and execute, and it has the actual functionality in there, which is what was in the switch statement. And the type objects are just very slim as well. They just have a visit that returns that. And yes, so that's that. The actual occlusion part, I'll talk about briefly. We have the occlusion line that I was talking about in here. So you have a line and then occlusion line, and it just gets the start point, and the end point is always the listener, and the collidable that has this is the emitter. So the emitter is just the sound playing, and it knows its position and acts like a collidable in such a way. And the Flim sound is the Flim API for the sound. Get the position, set the position, the orientation. Yes. Panning. You can do tweens too, so you can pan from the left speaker to the right speaker over a certain amount of time. And you can start, like in 2 seconds, I want to pan from the left to the right over the course of 3 seconds or something. Same with pitch and volume, playing. This is just kind of all it has. And yeah, I guess last I'll just show you, this is the API on top of the rest of the engine. You just give it, the sound call is what I had last quarter, and the Flim sound sits on top of it and interacts with the engine in like in such a way that it's a collidable and a game object, and takes advantage of the Flim features. Also, I added this 3D manager here that handles some of the X Audio 2 stuff. And where the reverb is, I'll show you that too. That's here. And this is all in the audio thread. This is actually the X Audio 2 functionality. But I think that's if I keep going, I'll just keep going. So I think that's all that's relevant for now.